everyone, this is Bilal and I welcome you all in our course that is building, planning and drawing using the AutoCAD. Okay, so hope all of you are well, and in last class we have discussed about the about the residential building. We have discussed about the different components of the residential building, correct? So we have seen that one, what all things will be included in the residential building. We have seen that one, the residential building is categorized into three components, mainly in three components, that is the living area, then service area, and then sleeping area, correct? So these are the three important categories which will be there for the there in the any residential building. And rather than that, we have seen the lot of other components like restrooms, correct? We have seen the prayer rooms, correct? So we have seen the garages, are different components, we have seen that one. Okay, so hope all of you understand that one. And we have seen the what are the advantages of particular rooms, and what are their minimum dimensions, and what are the directions of the rooms, and where to place that one, and what is the minimum circulation area should be provided, how to provide the minimum circulation area, correct? All that things we have seen in the last class. So in today's class onwards, or in today's this video, we can go with the next chapter. We are going, or we are starting from here, the examples of the building plans. Okay, so we are going to see that one, how to do the plan, what are the procedure of doing the plans, what are the procedure of doing the elevation, and what are the procedure of doing the sections. And one by one we'll see the different plans. We'll start with the single room plan, and after that we will go for the multi rooms plans. Okay, and we'll see that one, how the architects will provide the working plans on the site. So what is mean by working plans, what are in the working plans, what all things will be included, and all that things we are going to see in the coming classes. Okay, so let's begin with the single room plan of small residential building. So here in the figure you can see this one, there is a single room plan. So actually here it is a two rooms. So this is a one room, and this is another room, and this is a outer area of the rooms. Okay, so I will consider this is a small building having the two rooms. Okay, and the dimensions is given there. So according to that dimensions, we are going to draw in the AutoCAD, and we see that one, how to draw that one, what are the procedure of doing that one. So before starting the drawing, I just want to tell you there is a two systems. Okay, while doing any plan, there is a two methods. The one is by using the tool commands, we are going to draw that one, and another one is coordinate systems. Okay, so there is a two methods. We'll see that one, coordinate system also, using the coordinates, how to do the plan, and using the tools also, how to do the plans. Okay, so in all these systems we are going to use the tools only. In the all the plans and whatever we are going to do that one, we are using the tools only. We are not using the coordinates, because using the coordinates it will get slow to do that one, and for the multi rooms and all, it is difficult to do the to using the coordinates to complete the plans and sections and the elevations and all. Okay, so let's begin with the AutoCAD. So I just open that one. So here you can see this one. So there is a two room plan is there. Okay, so having the length of 7000 mm. Okay, so 7 meter if you consider in the, so this dimensions is in the mm, so we can consider only we are going to consider in the mm. So if it is meter, then go for the meter. If it is centimeter, go for the centimeter. So here it is mm, so we are considering this 7000 mm. So that is the length, and the width of the room is 3500 mm. Okay, and here you can see this one, you can observe that one. I will consider this one. This is the main entry of the room. Okay, so this is the door, the main entry of the room. So from here you enter to the one room, and here one more entry is there of width 1.1 meter or 1100 mm, and this entry is the width of 1000 mm, and another room is there, correct? And this one, this side we we can consider as, or this is our walls. Okay, this is our walls. Okay, so here the thickness of the wall is also given, that is 200 mm. So always you just remember the thickness of the walls will be varies. Okay, from structure to structure it is varies. So in these structures we are knowing that one, there is a two type of structures. One is load bearing structure, another one is which one? Frame structures. Okay. So if it is a load bearing structure, most of the cases we are using the 300 thick walls. Okay. So if it is a frame structure, we are using the 200 thick walls, and if it is a partition, then we are using the 150 and 100 walls. Okay, thickness of the walls. So always just remember that one. So if it is a load bearing structure, we are using the 300 if it is a if it will be mentioned, most of the cases we are using the 300 in the load bearing. In some cases we are using the 200 so that depending upon the structure to structure. Okay, if the span and all is be more, in that cases we are going for the higher thickness. If it is loads are less and only a single story building will be there, in that cases we are using the 200 also. There is no issue. Okay, and next one is frame structure. What is load bearing structure and what is frame structure? That also I will tell you. So what is load bearing structure? Load bearing structure is nothing but the whole structure is based upon the whatever the loads will be there, that will be transferred to the walls and to the foundation. Okay, that type of structures we called as load bearing structures. Okay, so whatever the loads will be coming on the structure, it will transfer to the walls. From the walls it will transfer to the ground, and from the ground it will transfer to the foundation and base. Okay, so that type of structure we call as load bearing structures. So nowadays the load bearing structures are very less. Most of the cases it is outdated. No one is going to construct the load bearing structures. For the small type of structure, we are going with the load bearing structure, and it will be economical also, and very less usable structure also, where the usage of the structure is very less. In that cases also we are going with the load bearing structure. Okay, and the construction method is also very easy in the load bearing structure, and the whatever the materials will be consumed, that is also very less, and it will get economical. So we are using that load bearing structures. And next one is the frame structures. Frame structure is nothing but the structure is which is made up of the frames. What type of frames? Whether it is RCC frame or it is a steel frames. Okay, both the things, whether it is RCC frame or whether it is steel frame or whether it is a composite structure, combination of RCC and the steel. Okay, that type of structures we called as frame structure. In the frame structures, mostly the load will be transferred from the top. The whatever the load will be there from the top, it will transfer to the beams. From the beams it will transfer to the columns. From the columns it will transfer to the foundation or footing. From the footing it will transfer to the ground. Okay, that type of structures we called as load frame structures. Okay, so I have quickly just clear this thing. Okay, next we go. So here you can see this one. Here this structure we can consider as a load bearing structure. Okay, so we'll go with the load bearing structure first, then we can come with other examples of RCC structure also. Okay, so the dimensions, everything is given. We just go and see how to draw this plan. Okay, so what is asked in the question? So draw a 2D plan using the absolute coordinate method. Okay, so here it is asked, we need to draw a 2D plan. So this is our plan. This is our plan. So only it is asked here only to draw the plan. Okay, so we just focus on the plan only. So draw a 2D plan using the absolute coordinate method. Okay, absolute coordinate, both the things we see our absolute coordinate method also we just see, and we just see the by using the tools also we just see that one. Okay, so the dimensions is also given, everything is given here. Only we need to go and AutoCAD and we just draw that one. Okay, I just go to the AutoCAD software here and let's see how to draw that one. Okay, so here, so this is our AutoCAD. So what is the first step of doing the AutoCAD or starting the AutoCAD? What is the first step? I already told you in the beginning only. The first step is we need to set the units. Okay, how to set the units? That is depending upon the drawings. So in our drawing, what dimensions they have mentioned or what dimensions they have used? They have used the So we need to set the units. So how to set the units? Go to the command prompt. You type the unit and press enter. So we'll get this one. So here you just keep it as decimal only. Okay, and precision I will just keep 0.00, and here it is millimeters. Okay, press OK, and the units are set. Okay, units are set. So what is the next step? Next step. So the next step is we need to set the limits. Correct? We need to set the limits. Okay. I just set the limits according to our page size. I will set the limits. What is our page size? Our page size is A3 page size. Always you just remember whatever the drawing we are going to do, whichever in the field, it will goes in the A3 page size. If it is some drawings only the plans you are giving, or only the presentation drawing if you are giving, then you can use the A4 papers. But most of the cases we are using the A3 papers. So what is the dimensions of the A3 papers? That we just add that one and we just see. So I just type limits. Just go to the command prompt. I just type limits, press enter. So it is asking specify the lower left corner. What is our specify the lower left corner? 0,0. Press enter. Okay, next it is asking specify the upper left corner. So what is mentioned here? So we are doing in the mm. So whatever the dimensions you are giving, or everything should be given in the mm. So what is the dimensions of the A3 size paper in mm? That is 4200 divided by 4200 by 200 2970. Sorry, so 4200 by 2970. This is the dimensions of the A3 paper in the mm. So here you can see this one, it is already showing here 420 by 297. It is in the centimeters. Okay, if you give in the centimeter, then if you draw the drawing in mm, then again it will be get confused, because we have set the units in the mm. Okay, so always you just give this in the mm. You have given, press enter. Okay, so 4200 by 200, 2970. Okay, so next we are going to set the limits. The next step of the limit setting the limits is we go to the rectangular command, press enter, specify the limit 0,0, press enter, 0,0, press enter, area per dimensions. Okay, we can consider here is 0,0. Next one 4200, so by 2970, enter. Next command is zoom, enter. Next command is all, enter. Z, enter. A, enter. So okay, so we have done some mistake here. I just check. Okay, some mistake we have done here. So that's what the limits are not set properly. Okay, I just delete this one. Okay, I just set the limits one more time. So one more thing I'm just thinking here, I just go to the plan. Okay, I just show you here. So you just observe the plan here. So you have observed the plan, correct? So you have observed that one. In the plan, what happened? So the whatever the dimension is given, that is 7000 by 3500, correct? 7000 by 3500, that is the dimensions of the rooms. Okay, overall dimension, that is outer to outer dimensions of the rooms, correct? So if we give the size of the paper, that is 4200 by 2970, then what happened? The plan will come out from the, obviously it will come out from the particular limits, correct? So here we are going to change that one. Okay, so now we'll change that one. Whatever the dimensions we are given, we'll change that one. We are not using the A3 size paper here. We are using the limits according to our dimensions. Whatever the dimensions is there, according to that our dimensions, we are using that one. Then while taking the printout, we just convert that one drawing to the A3 size paper, and then we'll take the print. Okay, that I will tell you how to do that one, how to take the, how to set to the scale, and how to take the print that one. Okay, so here we are changing the limits. that is according to our drawings. We just see that one. So our maximum drawing or our maximum limits is that is in the drawing, that is 7,000 by 3,500. So if we take that much only, then what amount the limits will be exactly at the plan size only. We'll go with the higher one. Okay, we just go with the higher one so that it will set in the particular limits. Okay, so what we do here, okay, I just come to this one. And one more thing, I'm just doing one thing here. I just go to the options and okay, selection, display. Okay, dark, we'll just keep here dark. That's okay, so it will be look easy for you. I just want to go in the display setting. Okay, so quality window, display resolution, so performance, process, layout elements, files. Okay, fine, we'll just close this one. Okay, so here we are changing the limits. Okay, I just type the limits, press enter again, 0, 0, press enter. So I just go here in our plan. So here you can see this one, that is 7,000 by 3,500. We just want higher one. So I just consider here 10,000. Okay, I just type here. Here also you can type anywhere. Okay, okay, sorry. Limits 0, 0. I just type here 10,000 comma the height 3,500. Just take 5,000. Okay, enter. So next rectangle, enter, 0, 0, enter. So whatever we have taken, the same dimensions we just take. Why it is not coming here? 10,000 comma 5,000. My rectangle command is not working properly. Just check. Rectangle, enter, 0, 0, enter, 10,000 comma 5,000, enter. Okay, Z, enter, A, enter. Okay, now you can see this one. So our limits boundary have set. Correct? Limits boundary we have set. Okay, clear? Okay, so I just want, so first method we are going to use is absolute coordinate method. Okay, so first we just use the absolute coordinate method. So in the absolute coordinator we need to find out the coordinates, the x coordinate and the y coordinate. So how to find out that? That is very easy. How to go in the x direction what is, and in the y direction what it is. So we just find out point by point. So exactly the first we just go. Okay, so this is outer point, outer, this is our lower left corner, this is our lower left corner, this is our upper right corner, this is our upper left corner, this is our lower right corner. Correct? All the corners, lower left corner, upper right corner, upper left corner and lower right corner. Correct? So first, always just remember, while using the absolute coordinate method, we need to first mark, or first we need to identify the corners. Whatever the coordinates are there, that corner coordinates we need to identify first. Then once you get that one, we can easily find that one. Or wherever the points are there, wherever the junctions are there, that coordinates we need to identify all the things. And once we get all that things, we just enter the things. Okay. Oh, sorry. Okay, so that is our next example. So this is I just want to type here, if you will get easily. Okay, so the first point, what's going on here? Okay, so the first point, lower left corner. What is lower left corner? So that is this point. You can consider 0 comma 0 also. From here 0 comma 0 we can consider that one. You just go here. What is this? What is this? 0 comma 3500. Then next, what is this point? What is this point? 7,000 by 3,500. Correct? 7,000 always. First one is the x coordinate, second one is y coordinate. 7,000 by 3,500. And what is this point? This point is 7,000 by 7,000 by 0. Correct? X coordinate 7,000 and y coordinate 0. So this is 0 comma 0. If we consider, okay, 0 comma 0. Next, this one point, next point, next point, and the next point. Okay, so or else we can do that one. If we consider 0 comma 0, then what happened? It will directly connect to our limit box. I just show you. So this is our 0 comma 0 coordinate, right? If we connect 0 comma 0 here, then it will directly start from here. So I don't want to start from here. I want to start, the drawing will come in the center. I just want to consider this drawing will be in the centers. Okay, so for that one, what I am doing here is, so I am considering this is as a 200 by 200. So x coordinate, that is lower left corner, I am just considering 200 by 200. Okay, and after that I am just considering remaining coordinates, this. Okay, I just write here. Okay, this I am considering. Okay, it will not come properly. This I am considering 200 by 200. Next, this is 200 by 3,500. Next, this corner 7,000 by 3,500, and this corner 200 by 7,000 by 200. 7,000 by 200. Okay, I just start here. Okay, before that one, after the setting the limits, what is the next procedure? We need to set the dimensions. Okay, modify, just go to the modify. I just set here all the lines, everything I just set here 100, so that it will be set properly in all the things. So arrow I just take 150. So little bigger size. This one we can consider 100. This one also we can consider 100. Next, text. I just consider the text height as 200, so it will be visible properly. And this will consider as, I will center. Okay, horizontal. Okay, according to that one. And fit primary units 0.0 and all that things. Press OK and just close. Okay, so that the dimensions will come correct. So we'll start with the coordinate system. We'll just go to the line command. Specify the first point. What is our first point? That is 200, 200. The first coordinate we need to type here, that is 200 by 200. Press enter. Okay, so here you can see this one. Okay, press enter. 200 by 200. What is our next coordinate? I just give the next coordinate. Here, what is our next coordinate according to the plan? I just open this one, this point. I just go here, from here. First outer surface I will just draw. After that inner surface I will just draw. Okay, then the partition will draw. Next one, this point. This point is how much? What is that point? X direction is, what is the x direction? X direction is the 0 and the y direction is 3,500. X direction is 0, that is 0 comma 3500. Press enter. Okay, it just taken the next steps. Next, this point, last point, this point, what is that point? That is upper right corner, 7000 by 3500 comma 3500. Okay, we'll get that one. Next, bottom point, that is this point, that is x direction is 7000 and y direction is 200. 7000 comma 200. Okay, sorry, we just missed here. Okay, this point, sorry, x direction is 7000. Okay, and the y direction is, you want in the down direction. If you go 3500, you get that one. It's not coming. Why it is? Okay, so we have selected that one. So we are coming in this direction. If we click here, if we go to the 7000 here and 200, it is up taking up here from this point. Okay, I just click here. From here I just add this point, 7000 comma 200. Why it is not taking the coordinate here? 7000. So coordinate system is not taking properly over here. Okay, I just move. Okay, so I just try here. So why it is not taking 7000? Okay, okay, this point is 200 comma 3500. So 200 comma 3500. So it's not taking here. Okay, so in here it is, it's not taking the coordinates properly. I don't know why it's not taking properly. So I just check that one and I'll just continue in the next class. What is the absolute coordinate method? We'll just see in the next class. So one more method we are going to use here, that is using the tools command. We are going to draw that one. So this method only, most of the cases we are going to use that one. Using the tools only, we are going to use everywhere the commands, because it is very fast and it is very useful also. Okay, so I just take the line command here. Okay, I just open the plan. So here you can see this one. Okay, so how to draw the plan? What are the procedure of doing the plan using the tools? So always we just remember, before starting the any plan, we need to calculate the outer dimensions of the plan. We need to calculate the outer dimensions of the plan. So in our this plan, the outer dimension is already calculated. In some cases, what happened, the outer dimensions will not be given, the full this much, whatever these dimensions are there, this type of dimensions will not be given. Okay, only the line diagrams will be given. So in that cases, we need to calculate the outer dimensions first. That is the first step of doing the planning. Okay, the first step, the outer dimensions were calculated, that is vertical dimensions and the horizontal dimensions, both horizontal and vertical, or x in the x direction and in the y direction, both the dimensions we need to calculate. So once we calculate the horizontal and vertical dimensions, then the next step is we need to draw the outer lines. We need to draw the outer lines. So once we draw the outer boundaries of the walls, next we need to draw the walls, inner walls, and then we need to draw the partition walls. Just see that one, how to draw that one. Okay, I just go to the line command. I just take the lower left one corner. One first point we have just taken. What is the height? 3500, correct? So what is the width? 7000. Okay, depth 3500 and 7000. Press enter, press enter. Okay, so I just take this one and I will just make it in the center. You're just using the move command. Okay, so this is our outer walls. Next we need to draw the inner walls. How to draw the inner walls? To draw the inner walls, we having one tool that we called as offsets, correct? So in the last class also, in the edit commands, we have used this one. So I just go to the offset command. I just click here offset command. So it is asking specify the offset distance. What is our offset distance here? So here you just see this one. What is our offset distance? Our offset distance is 200. That is thickness of the wall. Okay, so what is our thickness of the wall? That is 200 mm. So I just take it as 200 mm. Press enter. Next I give the offsets, 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 and offsets. Clear? Okay, fine. So what is the next? Next I just see that one, there is one partition wall. So here you can see this one, there is one partition wall. So what is the distance? So the partition wall distance is 3000. Here it is mentioned from, so outer wall, next 200 is the wall thickness, next 3000 is the inner dimensions, next again 200 is the wall distance, next 2400 till this level, door level, then 1000, then 200 is this one. Okay, I just draw the 3000 this wall. And what is the height of this wall? That is 2000, and this opening is 1100. Okay, I just go here, I just take again the offset. I go to the offset command. What is the specify this distance? That is 3000. I just click on the 3000. That is our distance from this to this. And what is the next? Offset command. Press enter. Wall thickness is through 200. Press enter. Press enter. Okay. So these walls also we have drawn. Clear? Oh, sorry. Okay. So we have drawn all the outer walls, that is all the four walls we have drawn, and this wall is also we have drawn. The next step, what is the next step of this one? We need to provide the openings. So here one opening is there, or here one door is there, and here one opening is there, or door. So here it is not mentioned whether it is a door or whether it is an opening. Okay, we can consider this one is a door and this one is a opening, or we can consider both as a doors. Okay, so it is not mentioned in this plan. So in other plans and all, it will be mentioned whether we need to provide an opening or whether need to provide a doors. Okay, what is mean by door and opening? So in that difference is, okay, I just go here, need to provide the opening. So this one, so again I just go to the offset command. What is this offsets? Offset is 1000. Press enter. I just take offset 1000, and this offset is this opening or this door offset is, I just go to the offset command again, that is 1100. Okay, so I just confirm this one. Here you see 1000 and this one is 1100. Clear? So now what is next? So once you've done this one, next command is whatever the extra lines will be there, that lines we need to cut, or that line we need to delete, or that lines we need to the trim. So for that one, we having the trim command. We just go to the trim command. I just press on the trim command, press enter, and I just trim this one, this one, this one, this one, this one, whatever the extra parts are there. So here in the corners also we need to delete this one. Why we need to delete this one? While the showing the plans, it should be look like a whole single plan. Okay, so there is no should be there. Whatever the walls will be there, that should be look like it is a continuous walls. Okay, it should be a continuous walls. So here you can see this one. This wall will connected with this wall, and this wall will be connected with this wall. This wall connected with this wall. So this wall connected with this wall. It will be interlocked here. So if you provide this line, then it means that there is no connection between these two walls. Okay, there is no interlock between these two locks, and whatever the extra lines will be there, that we are going to delete here. Deletes, and here also I just deleted. Okay, so our plan is ready. So I just open this one. Okay, so what is the next step? So we have provided the opening here, we also provide the opening here, we provide the walls also. Okay, next step is we need to provide the dimensions. All the dimensions we need to provide. Then the first exercise is over. I just provide the dimensions. I just go to the dimensions command. I take the linear. I go here. So how you can see this one? Using the line command, we can easily do the things as soon as possible. So again, this from here, it is this. Sorry. Okay. So it is 3000. So again 200. So again from here to here. From here to here. From here to here. So if you want to take the same command, you just need to press space. You just need to press space bar. Once you press the space bar, you just get this one. So I just check what is this dimension, 1100, and this one is 2000. Okay, so this is how we need to draw the plan. Okay, according to the exercise, only the plan they have asked. So we have drawn the plan over here. Here you can see this one with all the dimensions. This is how we need to do the plans. Okay, so next step, we just go and save the drawing. I just go to the save drawing. Okay, it will ask where we need to save. I just give this drawing name exercise 1, and I just save this one. Clear? So this is how we need to do the planning. Okay, this is a small single two-room plans. We'll go to the next exercise quickly in this class only. We'll go to the next class, so not next class, next exercise, where we can going to see the multi-room plans. I just open that one. Okay, so here, hope all of you will see this particular drawing. Okay, so that is next exercise. I just read the question. The line sketch of residential building is shown in the figure. Draw to a scale 1:100 using the AutoCAD. So what we need to draw here? First one is plan at sea level. B, that is front elevation and the sections. Okay. So here, which section they have not shown in the plan, that section will take that one. So okay, and what other things also it is given here. Note, all load bearing walls are 230 mm thick, BBM. Okay, so what is BBM here? That I will tell you. And that is built on side stone masonry. Okay, built on side stone masonry foundation. Roof is RCC and roof height is 3 meter above the floor level. Lintel is 2.1 meter above the plinth level. Okay, so all load bearing walls. So here the structure is load bearing walls. So it is given in the question only, the structure is load bearing wall. So here one more thing they have mentioned. So draw to a scale of 1:100. So whatever the dimensions, uh, whatever the dimensions we are taking, that is to we need to draw to a scale of 1:100. So what is mean by scale of 1:100? That is 1 unit is equal to 1 unit, correct? So when if it is 1 meter is equal to 1 meter, or 1 mm is equal to 1 meter, like that we need to take the direct scales. Okay, 1:100. So what we need to plan at sea level, front elevation section. So what is given here? All load bearing walls. Okay, everything is load bearing wall of thickness 230 mm and BBM. Okay, so 200 mm thick walls. Whatever these walls, you can see this one here. Whatever the walls, you can see this one here. Everything is built of 230 mm. Okay, so here in you will just understand the plan. Okay, so wall thickness is 230 mm thick, first class brick masonry built on size stone masonry, that is SSM, in foundation. Okay, so this is our, whatever the plan is there, this plan is at sill level. Okay, so this plan is at sill level. What is mean by sill level? What is mean by sill level? In the bottom of the window level, the bottom of the window level, that level we can consider as sill level. Okay, so the plan at sill level we need to draw that one. The front elevation we need to draw, we need to section. Okay, so about the foundation, the whatever the brick masonry will be there. What is the burned brick masonry? Okay, BBN in the sense burned brick masonry. So what is the burned brick masonry will be there? That is of made up of 230 mm thick, and below the burned brick masonry in the foundation, that is stone masonry, with the size stone masonry we have used. Okay, so roof is RCC. Above this one there is a RCC roof slab, and roof height is 3 meter from the floor level. From the floor level, the height of the roof is, you can consider as 3 meter, and lintel is 2.1 meter above the plinth level. Clear? Lintel is 2.1 meter above the plinth level. Okay, so this is our given question. So according to that, quickly we'll draw the plan, front elevation, and the section. We'll just see that one, how to draw that one, what are the in the plan, so what all things we need to add, and what all things we need to show that one, and how to draw that one, what is the procedure. So what is the procedure here to doing the plan? So to doing the plan, the procedure of doing the plan is, first we need to calculate the outer dimensions. What is this length? What is this width? This length, this width, this length, this width. All the outer dimensions we need to calculate first. Okay, so how to calculate that one? So I just calculate the length, just calculate the width. Okay, so this point we can consider as 0, 0, or 0, 0, or lower left corner we can consider 0. First we'll just calculate this length and this width, this length, this width, this length, this width. Okay, how to calculate that one? Okay, so here, okay, here only if possible I just add. So if I add here only, you will get an idea how to calculate that one. Okay, I just take a new slide. Okay, so L, so I just consider length L. Okay, length of the building, length equal to, what is the length here? What is the length here? How to calculate that one? Okay, we'll just calculate this length, this width, this length, and this width. Okay, so what is the length? So 1.76 meter from here, from this point. Okay, so here you can see this one. I just zoom this one. Okay, I just zoomed here. So here you can see this one. So there is two lines, correct? Here you can see this one. There is two lines. There is two lines. So the first line, the first outer line, what you can see this one. Last line we can call it as plinth line or plinth projection or plinth offset. Okay, this is the plinth offset. Okay, and this is our actual BBM level or actual sill level. Okay, we are going to do the plan at sill level. So our actual sill level we need to take here. Okay, so from here we need to take the actual sill level. And one more thing, so here you can see this one, whatever these dimensions is given, master bedroom, drawing room, bedroom, veranda, everything is given. So the first one 3 by 3.6 meter, 3.6 meter by 5.36, 3 meter by 3.6, correct? These dimensions are given. So these dimensions, how to read this dimension or how to use how to draw this dimension? 3 meter is the width of the room and 3.6 is the length of the room, and 3.6 here is the width of the room, 5.36 is the length of the room, and here 3 meter is the width of the room, 3.6 is the length of the room. And if we come to the dining room, here you can see this one, veranda, main door, drawing room, so one master bedroom, and from here we'll go dining room, okay, next bedroom, kitchen room, common bathroom, and one more bedrooms. Okay, so how many bedrooms? 1 2 3, three bedrooms, one drawing room, one dining room, one kitchen room, and one common bathroom. So here dining room 3.6 by 5.03, width 3.6 and height is 5.03, this also. So like that we need to understand. So here veranda, only the single dimension is given. What is mean by that one? 1.76 meter wide. So the width, this width we can count as 1.76 meter veranda. Okay, so how to calculate that one? From this point, okay, we don't want the offset, we don't need to take the offset, we just want to clear, just want to start from the clear point over. I just zoom that one. From this point we need to start and we need to calculate. So length is equal to 1.76 meter, this width, plus 230 mm, okay, that is 0.23 meter, plus length is 3.6 meter, plus okay, here you can see this one, this partition walls, this is the partition walls, this is the partition wall. Here you can observe that one, there is a two partition walls are there in the bathrooms. So this is not a partition. Here you can see this one, the main wall thickness and this wall thickness, there is a difference. So why it is a difference? So always you just remember the partition walls we are provided in the bathrooms, in the storerooms, and in the storage rooms, and where the small rooms or prayer rooms, in all that cases we are using the partition walls. Okay, where the usage of the walls is very less, where that wall is not transferring any load and all, so in that cases we are providing the partition walls. And to save the area or of the room, in that cases also we are using the partition walls. Okay, so we are considering here in this example the main wall as 230 mm and the partition walls as 150 mm. Just keep in your mind the main wall as 230 mm and the partition wall as 150 mm. Okay, so again we just calculate that one. From here 1.6 meter, 230 mm is the wall thickness, plus 3.6 meter, 150 mm is the wall thickness, plus 1.65 is the width of the room, and 230 mm is wall thickness, and again 3.15 is the length, and again 230 mm. So we'll calculate this length, then similarly we'll calculate this length, and we'll just check that, see that one. So I just type here length is equal to 1.76 meter plus 0.23, 0.23 plus what is that, 3.6 plus 3.6 plus 0.23 plus sorry, not 0.23, here it is partition wall, 0.15 plus 0.15 plus what is that, 1.65 plus 230, 1.65 1.65 plus 0.23 plus 3.15 plus 0.23 equal to how much? Okay, correct. 3.15 plus 230 mm. Clear? So equal to 11 meter. 11 meter. Correct. Similarly, width we just calculate, just equal to, to calculate the width, same procedure. 0.23 we can consider here, 0.23 plus 3 meter, 0.23 plus 3.6, 0.23 plus 3 meter plus 0.23. Okay, I just calculate here, 0.23 plus 3 meter plus 0.23 plus 3.6 meter plus 0.23 plus 3 meter, 3 meter plus 0.23. Correct? 0.23, 0.233, 0.233.6, 0.233 and 0.23. 0.233, 0.233.6, 0.233 plus 0.3 is equal to 10.52 meter. Okay, so width is 11 meter, length is 11 meter and the width is 10.52 meter. Okay, so this length we have calculated, this width we have calculated, and this length we can calculate, and this width, this length and this length. Okay, or else if we don't mind, we can, using the tools also, we can draw that one. Once we get length and width of the one dimensions, we can draw this one easily. We can, because we are knowing this one, correct? Or we just draw that one, we can just minus this one. Later we can trim this part. That also we can do that one. So this is our first step. What we need to do that one. Okay, so what is the procedure? First we need to calculate the outer dimensions, x or length and the width of the room. So once, that is the first step of doing the planning. So once we calculate the length and width of the room, so the next step is we need to draw the outer line of the, or outer wall of the particular building. After that, inner walls we need to draw using the offset command. Once using the offset command, next we need to draw the openings, that is doors, all the doors and the openings wherever it is there, we need to draw that one, openings and the doors. And next, once we draw the doors and openings, next step is we need to draw the windows. Here you can see this one. So in the previous example there is no windows, here it is, windows are there. After drawing the window, after doing the doors, or after providing the doors, next step is providing of the, or provision of the windows. Here you can see this one, there is a different windows are there for all the rooms. Windows are there, ventilators are there. So once you draw the doors and windows and ventilators, the next step, so the next step is we need to draw the plinth line, we need to draw the slab line where the slab will come, or slab projection, we need to draw the chhajja projection, and we need to do the dimensions. Okay, so this is the procedure. Okay, clear? So I just go to the AutoCAD side. I'll go to the AutoCAD here. Okay, I just take a new page here for the exercise 2. I just go here, open, new drawing, new drawing. Okay, so here, sorry, new drawing, not open, new drawing, AutoCAD, open. So you have opened the new drawing. What is the step? First step of starting any drawing, you need to set the units. I just click on the units. So in this example, what is our units? Our units are in meter, correct? So whatever everything we have calculated in meters, so our dimensions are in meter. So we need to calculate the meters. 0.0, I just keep it as in meters. Clear? Yeah, just keep it as in meter. Press OK. So once we set this one, what is the next step? Next step is we need to calculate the, or sorry, we need to set the limits. So to set these limits, so to set the limits for the ACSI paper, okay. So but here you just see this one, what is our length and width of the particular this one. So our length is 11 meter and the width is 10.5 meter, okay, approximately 11 meters. So that is our plan area where our plan will set. After that our elevation will come, after that our section will come, correct? So all these things will be going to set in this room, sorry, in that particular limits. So what we can do is here, we can calculate that one. 11 meter is length, x direction, width is 11 meters, plus we can consider another 11 meters for the section, okay. So and plus another 10 meter for the extra one, okay. You can consider as a width as a approximately approx, I just type here approx limits is 50 by 50 by 50 we can set, okay. So that all these things will be drawn properly, or we can just increase this one, or we can 75 by 75 or 100 by 100 we can take, okay. So we can take these things, okay. So according to that one, 10, okay, I just take the 75 by 75, okay. First drawing I just close. So this is our new drawing. Units are set. I just check one more time. Okay, units are set. Limits, just type limits, press enter. First limit is 0, 0. Next 75 by 75, enter. Next REC rectangle command 0, 0. Next 75 by 75, enter. Next command zoom, enter, all, enter. Okay, so our limits are set here, and using this in this particular area we can going to draw the our drawing, okay. So our outer length we have calculated, length is 11 meter and width is 10.5 meter, okay. Using the line command I just draw this one. The same procedure, using the line command we need to draw the outer lines. After using the offset command we need to draw the inner walls, and then we can, I just start from here. What is the length? For the length I just on the ortho mode I just type 11 meter plus enter. 10 point how much? 10.52 press enter. 11 meter, press enter. Later on I will just 0.52, press enter, okay. I just move this one from here to the center so that it will be okay. So whatever the plan size we have taken here, 75, yeah, correct, 75. This is also 75. That is 75 is little higher on what I'm thinking. So we can change the limits also here. That, okay, if you want you can change the limit. I just delete this one. I just put one more time limits 0, 0, 50, 50 I will take now because it is looking very higher side. So 50 by 50 I'm just taking. REC, enter. 0, 0, enter. 50, 50, okay. So now the limits are okay. So I just put here in the lower side, I just put the plan over here. This is our outer dimensions. Next Using the offset command, you just go to the offset command. What is our wall thickness? That is 0.23. I just given that one, and I just add the outer walls. Okay, once we added the outer walls, we added the outer walls here. Next, so next, I just open this one. Okay, so next, vertical lines also you can draw, or horizontal lines also you can draw. So you just see this one, which lines are very easier we can draw. So that line we just draw first. Okay, so here in our case the vertical lines are little easier. What we can see this one. So we'll draw the vertical lines first. Next, horizontal lines, and this one. Clear? I just draw the vertical line first. So these lines we have drawn, outer line. Next one, from this inner to inner, there is 3 meter distance. I just take offset and draw the 3 meter wall. Next, after that 3.6 meter inner to inner distance, I just take offset from this one, 3.6 meter, and then I draw one more wall. And next offset I will just take and draw a 3 meter and then draw one more wall. Okay. I go to the AutoCAD. So offset 3 meter. Is it 3 meter? Yeah, 3 meter. Press enter. I just take offset, enter, offset 0.23. Press enter, wall thickness. How we have calculated the length and width, like that only we need to draw also. Next, we go to again offset, press enter. What is the dimensions? That is 3.6, 3.6, enter. We'll just draw this one, 3.6. Okay, then again we go to the offset. To draw that one, press O. That is the shortcut key of the offset. Press O, enter. What is the wall thickness? 0.23, enter. Just draw the draw. And next we just check that one. It is 3 meter, correct? So dimensions are looking very low. I just go to the dim style, and I will just set that one so that it will be easy. Okay, lines, text height. Okay, so it is in meter. I just consider 0.1, 0.1, 0.1, symbols 0.2, 0.1, 0.1, and text I just consider as 0.3, so that it will visible clearly. 0.1. Press OK and close. And now just take, we'll check that one. This is 3. Yeah, this dimension is 3. Next, this is 3.6. Yeah, this dimension is 3.6. Next, this is 3. Okay, clear? So this is how we need to, we have drawn the vertical plan. Next, we quickly will draw the horizontal plans. Oh, sorry, vertical walls. Now we just draw the horizontal walls. So horizontal wall, from here we just start. So what is the distance? Okay, here you can see this one. This distance is different. Okay, this distance is different. These are same. This distance is different, but this wall thickness and this wall thickness is different. Correct? So like that, we need to carefully draw that. So I draw this one first, 3.15. Then I just draw this one next, 5.03 next, and next I draw 3.15, and then here the wall thickness is different, so be careful. Okay, so while drawing that one, I just go here first. Here I just go to the offset, press enter. What is the dimensions? 3.15 vertical dimensions, 3.15. Press enter. And what is the wall thickness here? Offset, enter. 0.23 is the wall thickness. Just enter. Okay, so now don't get confused. For not getting confused, I just trim this wall first. Let's go to the trim command. or just type the shortcut of the trim command is TR. Trim command, press enter, delete this one, delete this one. Okay, and this also, you just delete that one. So we will not get confused here, because this is our first plan, right? So we will not get confused. So that's why I'm deleting this one. From the next class onwards, you can draw that one easily. Once you will get the familiar to this. Okay, so this is how much. Okay, I just trim these corners, I just trim so that you can easily get an idea. This also I trim. Okay, see, AutoCAD software is very easy, you can nobody to do that. Okay, and here this wall should be trimmed always, so that it should looks continuous wall. Okay, next, this dining wall room, I just draw the dining wall. What is the dimensions of the dining wall? 15.03. Here you can see this one, there is a dotted line. So what is mean by dotted line and what is mean by this solid line? Correct? So if it is a dotted line in the plan, that it means that there is a no fixed wall, or there is a no fixed structure. Always you just remember, if it is a straight solid line, then it is means that there is a fixed wall. Okay, fixed wall in the sense the wall will not be moved. That is a permanent wall over there. It will not move. Okay, that indicates the solid lines. If it is a dotted line, that means that there is a no fixed wall. It is a movable wall, or it is having some arch over there, or it is having some partitions over there which we can move or which we can remove anytime. So that means that. Okay, so we are not providing here the walls. The dotted wall we are providing it. Okay, what is that depth? That is 5.03. Okay, thickness is 0.23 only, it is there. So just go to the offset. I just take 5.03, press enter. Okay, again I will just take offset 0.23 is the wall thickness. Okay, this is the dotted wall. We'll just do it later. Okay, I just tell you how to do that one. We'll do that one later. Okay, so this room you have decided. Next, this one, that is also 0.3.15. You just go to the offset, press enter. The room depth is 3.15, press enter, offset, press enter. Then thickness, wall thickness here is changed. I'll just show you here. This is partition wall. This is a partition wall. Here it is not mentioned the partition wall, but here it is mentioned the partition wall. So that depends upon that one. But in this plan, here it is mentioned the partition wall. Then we need to take the partition wall only. So what is that mentioned? That is partition wall. We are considering in this particular plan, that is 150 mm. Okay, 150 mm I just consider. Just go here. Offset I just taken 0.15. Press enter. Press enter. Okay, so 1, 2, 3. These 3 rooms are ready. Okay, so next again we come to this room. Then okay, I just come here. Next here. Yes, here it is bathroom. So what is this bathroom? 1.65 and wall thickness is 0.15. And here there is no things. So again here 1.73 and the wall thickness is 0.15. Okay, we'll draw that one. Let's go to the offset. We'll go to the offset 1.65. Press enter. Okay, offset 0.15, that is partition wall. Enter. Clear? Okay. Okay. So next, this one. Here, what is the dimensions? So here there is no rooms. Here it is 1.73 and partition wall. I just come here. Offset 1.73. Press enter. Offset 0.15. Enter. Okay, so openings, after drawing the walls, then we can go for the openings. Okay, now we are not bother about the openings and all, how to draw the drawers, and all. We just complete this one first. Okay, so next below this one, here there is one room, here there is a living room, and here also there is a room, correct? So just draw that one. Okay, we'll come here. Okay, so there is a room. So from here wall thickness till here we have drawn that one. Then inner to inner dimension, whatever these dimensions are mentioned, that is inner to inner dimensions. Okay, from inner to inner, inner to inner, inner to inner, this is 3.6. 3.6 from here to here, 5.36, and from here to here 3.6. Okay, just go to the offset command, press enter. 3.6, press enter. Okay, offset, wall thickness is 0.23, offset 0.23 is the wall thickness. Okay, this one just check what is the dimension. It is 5.36. Okay, offset 5.36. It should be end here. If it is end here, then our things are correct, otherwise our things are not correct. We have done some mistakes here. Here you can see this one. So there is a slight difference. So what is mean by this one? This means that while calculating this length, we have done some mistakes. What is the error? We can just see 0.08. So this is 0.08 is very minor, so no issue about that one, but still we have done mistakes something in calculating this length, or there is a chance also, that is the most of the cases that this chance will be there. So whatever these dimensions have mentioned, okay, whatever these dimensions have mentioned, there is some mistake in these dimensions. Most of the cases in the line diagrams, there will be a mistakes in that one. Okay, that is typing error should be, sometimes it will be there. Okay, so we can consider that one also. Okay, we just check that one whether we have made mistakes where. I just go here, length, so 1.76. okay, so 1.76 is correct. Next 0.23, next 3.6, 1.76, 0.23, 3.6, correct. After 3.6, 0.15 and 1.65, 0.15 and 1.65 plus 0.23, okay, 0.23, okay. Next 3.15 plus 0.23, 3.15 plus 0.23. So whatever the calculation we have done, that is correct. Then it is means that, so whatever these dimensions we have mentioned in here, there is some mistake in that one. Okay, so we just go to the AutoCAD. Okay, so whatever the dimension it is coming, we just take that dimensions also, or else we can move that one also. We can, in this case, we just take that, and whatever the dimension is there, that only we can take. Or how much it is? 5.36. I just go to the offset, 5.36, press enter. It is coming here. Okay, I can move this one also, no issue, that also we can do. Okay, we'll move this one. Okay, we'll move this one. Okay, fine. I just do that one. Okay, next from here there is one more room is there. What is the dimension? 3.60. I just come here, I just draw, I just go to the offset, 3.60. okay, offset 0.23, and here you can see this one. This is our extra portion, what we need to delete, what we need to trim that one. If you trim that one, to trim that one, you just extend this portion first. Here you just extend, and here also you just extend, and remaining portion you just go to the trim command and you just trim this one. Okay, just trim this one. Okay, and I just extend this one also, otherwise it will get little difficult while trimming. Okay, and here. So we can consider this one as our wall. This I just delete. This also I will just release. This is our inner wall now, and offset 0.23. Enter. This is our external wall. So to join these walls, we have one command that we called as chamfer. Just click on first point, second point, second point, first point, second point. Okay, and first point, second point. Okay, so here, so what is here? Here our veranda is there. Clear? So here you can see this one. In the veranda, there is no walls are there, only the steps are there. There is no walls. Okay, so wall will be end here. Okay, so these walls we just trim that one. Okay, to trim that one, we just extend these things. Otherwise, it will little difficult to trim. The whole wall will get trimmed. It will not extend. Okay, I just extend that one, and I just would draw one veranda here, here, correct? And again, I just open this drawing. So in the veranda, there is a steps. So how many steps? 1, 2, 3. This is the top view. Okay, so this is the top view. So 1, 2, and the 3 steps are there. So we just draw the 3 steps. Just come here. How to draw that one? What is the width of the steps? So width of the steps, the thread and the risers. In the steps, there is two, that is thread and the risers. So if you see in the top, it will consider it. The threads will be seeing, and if you see in the elevation, the risers will see. Okay, always you just remember, don't get confused in the steps. So we are seeing in the from the top. Then threads. What is how much we are going to consider? Threads we are going to consider as a 0.3 or 300 mm, and riser we are considering as a 150 mm. Okay, this is the standard as per the IS code. It is the standard one. Thread is 300 mm, and for the riser 150 mm, so that the any age of the people can lift the steps easily. So offset 300. Okay, 0.3. Press enter. 1, 2, and 3 steps are there. So after that, this one. Okay, so all the walls we have done. I just check whether all the walls are completed or any partition walls are remaining. I think there is a partition walls are remaining. I just go to the partition walls here. I just open this one. Here you can see this one. Here one partition wall is remaining, and here one partition wall is remaining. Correct? And okay. So remaining everything is done. So these two partition walls. So what is this? From this wall, it is 1.65 and 150 mm, and it is 1.95 and 150 mm. Okay, we'll draw that one. We'll go to the offset command again. Offset 1.65. Press enter. And offset 0.15. Okay, this extra thing will just delete. Okay, from here also one partition is there. I just draw that one. Offset 0.15, sorry, not 0.15, 1.95. Let's enter. Width of the bathroom, and next offset partition wall thickness 0.15, and extra wall I just trim. TR, enter. Correct? Okay, so now I just save this drawing. Okay, so always you just make one good practice, that always save your drawings continuously. Okay, so in sometimes if anything will happen, then there is no loss of the drawings and all. So for that purpose, always just try to save your drawings in particular time. I just go to this to save option. I just give it as exercise 2. Exercise number 2. Okay. Okay. So now whatever the extra walls over there here, so all that will trim that one. I just open that plan here it is. Okay, here you can see this one, there is one opening is provided. So here you can just see. So next step is next step we need to provide the doors and windows to the plan. So here first we have provided the steps, then the main door. After the main door there is one door for the master bedroom, and one more door is there, that is for bathrooms. And here you can see this one, there is an opening. Okay, this is called opening. If it is not mentioned D1, so I will tell you what is D1. Here you can see this one. I just zoom that one. Okay, I just zoom this. Okay, so here you can see this one, MD in the sense main door. So D in the sense door, D1 in the sense door 1. Okay, so why it is like this? So because, so the size of these doors are different. So that's why we are different notations we have given. So here also for the windows, here you can see the W, here it is W. If it is size is different, then we can give it as W1. Here for ventilator we have given V. For the size of the windows is differs because of that one, and size of the doors are differs because of that one, we are giving this one. Okay, so I just write here considering or consider. So I just tell you, while in the schedule of opening, in that one, what is the window size we need to take, what is the kitchen window we need to take, what is the living room window we need to take, what is the bedroom window, what is the bedroom doors, bathroom doors, storeroom doors, puja room doors, main doors, all the dimensions we just mentioned in the schedule of opening when we're doing that one. But I just consider here, because you just see here, I just open, you just see here. So here in the doors, only one OMD, that is one type of door. Another one is D, another type of door, another is D1. So 3 types of doors are there. Okay. Next, all are same. But in the windows, all are same windows. All W. So in this particular plan, the window size, everything is same. But the door sizes are 3 different types of doors are there, and 2 ventilators are there. So I just write there what is the sizes of the windows, standard sizes and standard sizes of the doors. Okay, I just write here considering opening sizes. First one is, what is that? MD, main door. The size I will take 1.2 by 1.2 by 2.1 meter. Okay, next one is door D, that we can consider as door. That size, that is bedrooms, doors and all, 1 meter by 2.1 meter. So what is mean that 1 meter is the width of the door and 2.1 meter is height of the door. Okay, 1.2 meter is the width of the main door and 2.1 meter is the height of the door. D1 door, I just consider 0.75. Also we can consider 0.75 or 0.8. That depends upon the things, but most of the cases 0.75 to 0.8 we are keeping bathroom doors. Okay, so the size of the bathroom doors is little smaller compared with the bedroom doors and the bathroom doors. Okay, 0.75 just keep, and that's door sizes also varies. According to that you can provide. And 2.1. So 2.1 meter is the lintel height. So always you just remember whatever your lintel height will be there, that only the height of the doors. Always you just remember. And it little differs. Okay. little differs because of the flooring and because of the door frames and all. It will be, it become little, but whatever the opening size we are leaving in the drawing, so that drawing just give whatever the height of the lintels. So here what is the height of the level, here the floor level, lintel is 2.1 meter from the plinth level, it is already given. So that's why the height we are considering 2.1 meter. And in the standard also, as per the standard and whatever the practice is going on in the field, whatever the construction practice is going on the field, the lintel height is as per 2.1 meter only. Most of the cases in the, most of the residential buildings, we are considering 2.1 meter height of the lintel only. Okay. Then what is there? Main door. Okay, next window. Window is there. That is W. I just consider 1.5 by 1.2 meter. And next ventilator. Ventilator. V is equal to, I just consider 0.6 by 0.5 meter. Okay, so these are our standard dimensions. Most of the cases in the general practice, in the field, everything, these are the standard things which is used in the building plan, residential buildings. Okay, okay, these things we just apply on our, or these things we just approve on our drawings, or will draw over here. So here main door we just draw. From here it is 1.2 meter, and from this one 1 meter, and this one is 0.75 meters. Okay, so we'll draw that one. We'll see how to draw that one. So here this is extra openings are there. I just delete this one. Okay, and here, okay, so before doing this one we need to extend this one, and I just trim. Okay, and this is also like this. I just check. Okay, one opening and two opening. It is like this only, right? Okay, just extend. Okay, now we'll just draw the main door. Okay, offset 1.2 meter, press enter. 1.2 meter. Now just trim, and this one extra one, delete that one. Next will come here. This is dotted lines that I will tell you how to do that one. From here to entry of this one, where it is, just check. Okay, so okay, this end of the dotted line, here it is main door entrance. So I just go here, I just extend this one, EX, enter. Okay, from here the door size is given 1 meter, take an offset, I just provide it over here, and I trim. Okay, so next bathroom door, I just check where it is the bathroom door. Bathroom door, here it is, from this wall it is here 0.75. I just go to there, just offset 0.75, enter. Okay, so trim, enter. I just delete this one. Okay, this should look continuous, so I just trim this one. Okay, so this is that is line, so it is not a continuous wall. Now next, for this bedroom, okay, from here it is one door, from here it is one door, two doors are there, and this is the opening, and one door and one door. Okay, fine. So we'll draw one door over here. For that one, we just extend this line to draw the door offset. What is that? D1. D1 is the 1 meter. So enter. I just delete this one and delete this one. And similarly, I just go to the offset. This door 1 meter. Okay, I just trim this one. Trim this one. I just trim this one also. This is extra. I just delete it. Okay, and here we just check where is the bathroom. door. Okay, from here it is 0.75. Just go here, or just provide offset 0.75, enter. I just go here, press enter. Now just trim the extra part. Just trim, tr, enter. Okay, trim, okay, and this is also I just trim to look the continuous wall. These extra things I just going to delete. Okay, here also it is correct. So here you can see this one, all the doors we have provided. One main door, bedroom door, bathroom door, bedroom door, here one bedroom doors, and this is a opening, this is a bathroom door common, and this is bedroom door. Okay, this is, we'll just make it as dotted line, that I will tell you. Okay, so the next step after doing this one, the next step is providing the windows. Okay, so now where we need to provide the windows. So always you just remember, whichever the outer walls will be there, for that outer walls we are providing the windows. We are not providing the windows for the interior walls. Always you just remember that one. What is interior walls here? So you just enter the living room or drawing room here. For this wall we can't provide the window. For this wall we can't provide the window. Okay, from interior walls we can't provide the window. Only for the exterior walls we are providing the windows and the ventilators. That is the first step. You just remember that one. Next, and whichever the wall, whatever the wall we are going to provide the windows, at the center of the wall we are providing the windows. Why we are providing the at the center of the wall? If we provide the at the center of the wall, for the better circulation of the air and for the better sunlight, for that purpose we are providing the window at the center of the wall, and for the aesthetic point of view also it will look good. Okay, most of the cases, and depending upon the types of the windows, it will be changed, and design of the building also it will be changed, but most of the cases for the better ventilations and for the better sunlights and all, we are providing the windows at the center. Okay, okay, so what happened here? Okay, fine. So we'll provide the windows. So in our case, see here, in our case, so doors, all type of doors we have provided. In our case, what is the width of the window? Window width is 1.5 meters, and only one type of window is there. There is no more windows are not there. Only one type of window is there. So first we'll do one thing. First we'll prepare one window here. Okay, so we just go to the rectangle. I just tell you, I will prepare the window. Okay, so I just provide the dimensions. What is the dimensions? 1.5 meter width. Enter. What is the thickness? What is the width of the window? The width of the window is equal to the width of the wall. If from the top, if you see this one, the width, okay, the width and the height, depth is different. The thickness, whatever the thickness will be there, whatever the breadth will be there, the breadth is the equal to the thickness of the wall, that is 0.23. Enter. Okay, so here our window is ready. So this is our window. What is the size? 1.5 meter. Here you can see this one. Okay, why it is showing this much? Dim style. I just go to dim style, modify, primary units 0.0, 0.00 we can consider. Okay, okay. So 1.5 meter and 0.23. Correct. So this is our window. Next, in the window we are providing the railings also. This is the railing, or we can call this as grills, or for the safety purpose we can provide the bars also here. Correct. So that no one can enter to the house. Otherwise, if you're not providing the any bars, any grills or any railings over here, it will difficult to maintain the safety. Okay, so now I just copy this one. I just copy and I just paste wherever it is, wherever it required. So as per the plan, it is here one window, one, and another window is here. So center of the wall I'm providing. Here you can see this one. This triangle indicates the center of the wall. Correct? Okay. So here I just go to the plan. I just check where it is the windows. So one window we have provided here, center of the wall. Another window we have provided center of the wall. 1, 2, 3 backside. All the backside center, and here one. Correct? Okay. Just come here. Okay. Yeah. Okay. This is the center. Okay. This is the center. And again I just come here. This is our center. Okay. And this is our center. Oh, it is pasted here. I just move this one. 0.23. Okay. So these three windows and one more window is here. I just copy this window, copy, and I just paste here. Correct? So we have provided the windows. Okay. So doors we have provided the after the doors we have provided the windows. Okay. So walls also we have provided. Okay. So what is the next step? We just provide the ventilators. Okay. We just go to the ventilators. What is the dimensions of our ventilator is 0.6 by 0.5. Okay, 0.6 is the width of the ventilator. I just go to dimension 0.6, and what is the thickness? Same as window, that is, or same as wall thickness, 0.23. I just rotate this one because our ventilators are in vertical shapes. Ventilator also we need to provide at the exterior walls. I just draw the railing here, or rods here, rods here, not rebar. Copy, and so in the center I'm just providing this one. Okay, it is copied here. I just move this one. Okay, correct. So ventilators also I just delete this one. So ventilators also we have provided. Doors, windows, and ventilators are all. So next, what is next? What is the next step? What we need to show? Next we need to show the plinth projection. Okay, next we need to show the slab projection. Next we need to show the chhajja projection. Okay, so plinth, what is mean by plinth? Plinth level. Okay, in the plinth level what happened normally the plinth level will be the in the width, normally the plinth width is bigger than the size stone masonry or this wall. Correct? So because the foundation are having the width, after that it will steps, and it will plinth will come. The plinth is also having little width. After that wall will come. Okay, so that whatever the load will come, it will transfer evenly. If your wall is bigger and if your plinth is smaller, then what happened? It will not transfer the load easily. It will not easily transfer the load. There is a chances of imbalancing of the loads. So that's why the plinths will kept as a little higher side than the walls. So that projection we need to show here. So what is that projection? So normally I just write here. So okay, I just write here. So plinth width I'm considering as 0.45 meter. Plinth width I'm considering as 0.45 meter. Okay. Then what is our wall thickness? Wall thickness is 0.23. Okay, I just write here. Wall thickness is 0.23. So what is the difference? Send 0.2 difference. Zero 0.45 minus 0.23 equal to, just check, 0.45. It is 0.22. This is the difference. Okay. So, and what is the projection will be visible? Just write projection at each side is equal to 0.22 divided by 2. Why it is divided by 2? Both the side. Both the sides. So the wall will come in the center. The plinth width is 0.45. In the center of the wall, the 0.23 will come. And at the right side and at the left side, small portion will be left. That is how much? That is 0.22 is the total projection divided by 2. At the each side, 0.11 will come. At the each side, 0.11 will come. Okay, it is not okay. At the east side, 0.11 will come. Correct? So that 0.11 projection we need to show here. That is at the exterior. And at the interior also 0.11 will come. So this is the center of wall. 0.11 come here, 0.11 come here. But here inside we will not showing because we are considering it is at the sill level. If it is at the sill level, then above the plane there will be a flooring. If it is a flooring, then this will not visible. But outside there is no flooring, right? That's why we can need to show that one. So I will just go to the offset command and I just take 0.11 as a projection, plinth projection or plinth offset. I just draw here 0.11, 0.11, 0.11. Okay. In the steps, there is a no plinth. Yes or no? So for the steps, we are not providing the plane. Steps at the ground level. Slabs at the ground level, plinth at the plinth level. Okay. So now we'll join this one. We'll join all the things. We have the command for that one, chamfer command. Specify the first line. I just specify the first line, specify the second line. Press space bar, specify the first line, specify the second line. If you want to take the previous one, space bar, first point, second point, 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 space bar, first, second, and last one. Okay. So this is our plinth line. So we have drawn the plinth line. So what is the next step? So next step we need to show the slab projection. We need to show that one slab projection in the plan. So this is how we need to show the plan. Okay. So why we need to show the slab projection? Why we need to show the door? Why need to show the window positions? Why need to show the sizes and all? So that those who are referring the plan, the client or the workers or the contractors or the engineers, those who are seeing the plan, they should have a detailed. So that purpose we are providing this one. So they should know that one what is the plinth projection. They should know that one what is slab while doing the work, while execution of the work. In that cases, they should understand that one, all that things. Okay, for that purpose we are providing that one. Okay, so in that particular plan, minimum these things should be there. Anyhow, these should will be provided in all the plans. Rather than that, the furniture layouts will be there, the plumbing layouts will be there, the the wooden layouts like opening layouts will be there, the electric layouts will be there, the bathroom layouts will be there. Correct. So different layouts will be there, but this is the presentation drawing, where in the presentation drawing this much should be there. Whatever we are going to do here, that much should be there always in all the drawings. Okay, I just quickly draw the slab projection. What is slab projection? From the face of the wall, well, how much outside it will come. Why we need to provide the slab projection? To avoid the dampness of the wall in the rainy season, we are providing the slab projections. correct, from where the heavy rains will be there. In that cases, in that area, we need to provide the slab projection so that the rainwater will not be directly some into the wall. Okay, so there is a less chances of dampness of the walls. Okay, so for that purpose we are providing the slab projection. Okay, we just go to the offset, press enter. So what is the slab projection? What is the standard slab projection? I just write here, or I can just write here. I just write here. Slab projection is 0.4.5 meter. This is a standard slab projection which we use. You can go with the higher side also. Minimum you should use 0.45 meter, not less than this. If there is any object will be there, any something shortage of area will be there, anything will be there. In that cases we can go for the lower one, but this is the minimum one which we need to provide, 0.45 meter. Next one is Chhajja projection, that is at 6 meter, 0.6 meter. I just go here and I just draw quickly Chhajja projection. Chhajja will come above the windows only at the plinth level, that I will tell you. Okay, I just go offset, press enter. Slab projection is 0.45 meter. I just enter here. From the face of the wall 0.45, from the face of the wall 0.45, 0.45, 0.45, 0.45, again 0.45. Here we are considering the steps also. Okay, so we are covering the steps also. Okay, correct. Now we'll just join this one using the chamfer command. I just go here, I just click here, again I just click here, I just click here, just click here, I just click here. First point, second point, first point, second point, first point and second point. Correct? Yes, it's correct. So you have drawn the slab projection. Okay, so we have covered the steps also, otherwise steps will get dampness in the rains. Okay, so next we need to show the Chhajja projection. Chhajja projection we need to show at the windows. Okay, what is the Chhajja projection? Chhajja projection is 0.6 meter, 0.6. I just draw the Chhajja first here. Width of the window is how much? 1.5 meter, and Chhajja is 0.6. Okay, I just tell you one more time how to draw the Chhajja. Okay, so Chhajja width is 0.6, sorry, projection is 0.6. Press enter. 1.5, press enter. 0.6, press enter. Okay, so this is our window size, but okay, at this level only we just provide the Chhajja. I just copy this one, okay, and I just paste on the window level 1, and where it is here in the front 2, just off this one. But here we will not providing Chhajja because it is inside the veranda. So inside the veranda Chhajja will not provide it. Why we are providing the Chhajja? What is the purpose of providing the Chhajja? Or else what we can call as, what is the purpose of the providing the Chhajja? The purpose of providing the Chhajja is to avoid the dampness of the rainwater from the window, and to provide as a sunshade also. They are using the Chhajja. Okay, and for ventilators we are not providing the chajja. Sometimes it will provided, but sometimes it is not provided. Why it is not provided? Because the size is very small and the depth is also very small. That's why we are not providing that. Okay, so we have provided the plinth here, we have provided the chajja plinth projection, we have provided the slab projection, and we have provided the chajja projection. Correct? So these things we have provided. Okay, and one more thing I just want to tell you. This is whatever the plan we are doing here. This plan is at sill level. Okay, so whatever the things will come above the sill level. What is sill level here? Sill level is the bottom level of the window. Bottom level of the window. Always uses that is called as sill level. So above the sill level, whatever the things will come, that all things we need to show in the dotted lines. Okay, that all things we should be shown in the dotted lines. So what will come above the sill level? Above the sill level, our chajja projection will come. Sorry, our slab projection will come and our chajja projection will come. But this plinth projection, it is below the sill level, so no need to show the that things in the dotted lines. But our slab projection and our chajja projection, we need to show in the dotted lines. Okay. So how to show that one in the dotted line? I just trim this one. Here you can see this one. Okay. Okay. So how to show the dotted lines? I just show you. I just go to the here to draw the dotted lines. All of you just observe here. To draw the dotted line, we just go to the property section. You just observe here. Here you can see this one by layer. Here you can see this one line options. So this is the color change. If you want to change the color of the any object, you just go here. If you want to change the thickness of the object, you just go here. Thickness of the line. Here you can see this one. You can change the thickness of the line. So up to 2.11 mm it is there. We don't want to change that one. If you want to change the style of the line, then we need to go here. So you just click on the by layer, go to the other, and here you just go to the load, and in the load you can see this one. So dash line, dash space line, long dash dot line, long dash double dot line. Correct? So there is a different lines are there, dash 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 dash. There are different lines are there. So according to that, you just choose that one. Okay, we are considering the dash line only for the slab and chajja projection. So these lines having also different meanings. Okay, so we are providing the dash lines. You just press OK. So dash line is loaded. Press OK. Okay, so now, so which from where we want to do that, we need to select first. Okay, I just select this one as a sample. Select the object. Again, go to the property section. Go to the guy layer. Click on the dash line. Press enter. Okay, press escape. So here you can see this one. So it is not showing the dash line. I just select again. I go to the property section. Here you can see this one. It is a dash line, but here it is not visible. Why it is not visible? Because of the scale. Because of the scale. I just go to others. I just click on the dash line. I show details. I just change the scale here. I just change the scale as 0.1. Global scale factor just change. Press OK. Here you can see this one. Now it is small dashes came. Large dashes came. Again, I just go to the section. I just go here. I just change the scale. 0.05 I just make. I just check. Okay, 0.05 is also very large. I just go here. 0.02 I just take. Press OK. Okay. 0.02 is the correct one. So now I just select all the chajjas and the slab projection, and I just make it as dotted line. Correct. I've selected everything. Go to the properties. Go here, click on this one, press escape. Now here you can see this one. All the lines, I just delete this one. All the chhajja and the slab projection I have selected as a dotted. So because it is above the sill level. Okay. So now, okay, this one also we want this dotted line, right? Just select this one. I just go and do this one. What is mean by this? This is a permanent wall. Oh, sorry, not a permanent wall. That's why we are showing the dotted line. Okay. So after doing the slab projection and all that things, the next step is we need to add the text. What is mean by text? We need to add this text. We need to add this text. Drawing room, what is the dimension? Master bedroom, what is dimension? Bathroom, what is dimension? Everything you need to add this text. Okay. So I just go to AutoCAD. I just go to the text command. I just click here. I just select the area, center of this room. Just click here. What is this? Drawing room. What is the size? I just check. Size is 3.6 by 5.36. Size is 3.6 by 5.36 meter. Or no need to write the meter also, because 5.36. Okay, no need to write the meter, because in the bottom we just mentioned that one all the dimensions are in meters. I just specify this one. I just change the font. You can change. If you can't, you can change this one. I just add this font. Okay, drawing room. You can move this one anywhere. Correct. Now similarly for the next room, I will do one shortcut here. Instead of going there and selecting the area, I just copy this one. I just paste here. Okay, I just paste here and I just edit this one. This is our master bedroom. Correct. What is the size of the master bedroom? 3 by 3.6. 3 by 3.6. Correct. So similarly, I just copy this one. I just paste here in the dining room, and there also I just edit this one. This is what? Dining room. What is the size? 3.6 by 5.03. 3.6 by 5.03. Correct. Next, again I go to the bedroom. Bedroom 3 by 3.15. Okay, and kitchen also 3 by 3.15. Okay, I just go to the bedroom, just click it here. I just copy this one. I just paste here. I just edit this one. What is this? 3 by 3.15. Okay, similarly I just copy this one. I just paste here. This is kitchen. Kitchen 3 by 3.15. The same dimension. I just keep it here. Okay, next, this is bedroom. I just copy this one, or bedroom I just copy this one. I just keep it here. This is also 3 by how much? 3 by 3.6. 3 by 3.6 bedroom. Okay, what is left? So veranda, bathroom. Okay, I just copy in the bathroom. I just type here. Let's keep it here. I just reduce the size also. 0.15 just makes little smaller size. What is this? Bath per WC. Bath per WC. What is the size? 1.65 by 1.65. 65 by 0.65. Okay, bath per WC is this. Again, I just copy here. Bath per WC is one more is here. What is the dimension? 1.95 by 1.73. 1.95 by 1.73. Okay, so what is left? Left is veranda. So I just write it here. Veranda. Veranda. What is the, how much is the veranda? I just check. I just click here. Just click here. 1.84 wide. 1.84 wide. I just want to size. I just reduce 0.15. Okay, so that you just adjust that one where it will looks good. Okay, so next is remaining the naming of the doors and windows, which is door one. That I just go to the text command again. I just draw here main door. I just change the text. Okay, main door. I just copy this one again. Similarly, here one door is there. Here one door is there, right? This is door, and this is door one. Similarly, I just copy this one. Here one door is there, one more door is there, and one more door is there, and here D1. Correct, we have provided this one. Now windows. I just make it down. Here one window is there, that means as W, and I just copy this W to everywhere. Window, window, window. Here one window, one more window. Okay, now ventilators. We can consider as what's happened? We can consider as window. Sorry, ventilator. Just copy this one. I just paste here. Correct. So we are provided the names also, and we are indicates the doors and windows also, which is doors and which is windows. Correct. So yeah. So this is main door, this is window, everywhere window, doors, and bathroom doors, everything we have provided. Okay, we are almost done in the plan now. We are almost done. So the next step, that is the last step of the plan, is we need to show the hatch. We need to hatch the walls. Okay, once you hatch the wall, then everything is finished. But we are not hatching right now, because once we hatch that one, then it is sometimes it is little difficult to, what we say, sometimes it is difficult to edit these some things. Okay, sometime once you go to the elevation, then some difficult will come in a section also, some if modification required, then it is little difficult to hash that one. But once we hash that one, the plan will be finished, and we need to show the section line also. Okay, plan means finish, and section line also we need to show. Okay, I just hatch that one. We'll see that one. If any difficult will come, we delete the hatch, and we can do that one. Okay, I just go to the hatch command. Here you can see this one, hatch command. Click on the hatch command. Okay, so here you can see this one. These are the different hatches, which having a different name meanings also. Solid, angle, and there is a INS 131, 132, INSI 31, 32, okay, 33, 34, 35, everything different is there. Here you can see the brick is there, and here concrete is there, and here tar road is there, okay, and here you can see this one sand and brick, brass. Here you can use cross, stones, dots. Here you can see this one glass. So there is a different honeycomb, meaning is there for different things. Hash is very important. Okay, so which hash we are using for the plan? So for the plan we are using this hash INSI 32. Okay, that is for the plans, or we can see that one for the burned brick masonry or for the superstructure. So what is superstructure? We are divided a structure, a building structure, into three categories. One is substructure, one is superstructure, one is roof. Okay, so for the superstructure we are using this hash. Always you just remember whether it's burnt brick masonry or whether it's stone masonry, for the, or whether it is blocks or anything. If it is a concrete wall, then we need to show the concrete, but here concrete will not come. Here it is our brick, burnt brick masonry. I just click on this one. This is our hatch. Always you just remember. Okay, and for the foundation, one straight line, one dash line, one straight line, one dash line for the foundation. That is for the size stone masonry. I just go here, wherever the wall will be there, I just hash this one here, wall. Okay, so just click on this one and click on the points. Click on the points. I just show you, I zoom it. Here you can see this one point. I just zoom, I just point, I just click here, just click here, automatically it will take. If any gap will be there, if the line will be not joined, then it will not take. Okay, so if any joints, any gap, if it is there, it will not take. See here, it will take like this. So hash will go out. Okay, clear? Okay, so we have hash to all the walls. We have hash to all the walls. So just go to the hash. So here you can see this one. There is a scale. This is a scale. So if you change the scale, the hash will change. I will just show you. If I take, if I want closer hash, again I just take 0.5 and I just press enter. Okay, I just want to change 0.5. I just press enter. Here you can see this one. If I change again scale 0.1, again it will get close. If I change again 0.01, then here you can see that again it will get close. So 1, the scale will change. I want 1.5, then again scale will change. I want 2, scale will change. I want 10, scale will disappear. It will change. It will get larger. I want 100. See here, like this. Like this, the hash will work. Okay. One is correct size. I think this hash is perfect. Okay. Next, I just go to the hash command. I just click on the hash. So hash command will open, and here you can see this one, patterns, gradients, and solids. Here you can see solid. If you connect, it will come solid. Gradient, if you click, it will create gradients, patterns, and define. Okay, so that patterns also you can change. If you want to change the color, you can change the colors also. Okay, this color format will just see incoming is this one. Okay, so we have drawn the hatch also. So after doing the hatch, this is the last step of doing the plan. Next, I just show the one section line which is passing through the maximum components. You can draw a horizontal section line also, or you can draw a vertical section line also, that like this also. So there is no specific things are there. We need to draw here only, anywhere you can draw that one, but it should cover a maximum components. Here you can see this one, it is covered a wall. Here it is covered a door also. Here it is covered a wall, and here it is covered a wall. Okay, so maximum, so that door also it will come in this section, so that the whatever the clients will be there, contractors will be there, they can easily understand that one. Okay, if the door will cut in the section, how it will look. So maximum things we should be covered. And for that one, I just give one naming for the section line. I just give name as XX. It is in the x-axis, right? So I just give x. X-axis. And such section line we need to show in the dotted. Okay. So like this. And here I just add below this one. What is that? What is that in the question? Plan at sill level. Plan at sill level. Okay, I just want to change. I can change that one. Change the font, and we can keep it like this also. If you want to change, you can change the size also. 0.3 I just make. Okay, this is our plan at sill level. This is what our plan at sill level, where we have included everything. So this is a presentation drawing or presenting plan, we can say that one. So this is our presenting plan where these things should be there. Minimum these things should be there. Rather than that, you can show the furniture layouts. Rather than that, you can show the plumbing layouts and electric layouts are the different drawings. Here you can't show that one in the presenting drawing. Rather than that, you can show the in the presenting drawing, you can show the plumbing this one furniture layouts, and you can show the doors, door openings or door directions. That also you can show. You can show the column layout also in that one. This is our load bearing, so we are not shown that one, but in the next we can show that one column layouts also. Okay, so all that things you can show that one. Okay, so once we done this one plan, we just seen the our, okay, this is our limit area, so our plan is here. Next above. Okay, so first we plan above the plan section, sorry, elevation, and side the elevation we need to section, and here the side plan, that things. So all that things we need to draw here. Okay, so I think the video is going large. Okay, so now we just end here only. So the plan you have got understand. I hope you just understand whole plan. Okay, you just practice this one. Go and practice the plan. You just have doubts, you just see again and again video, we'll get this one. So this is the minimum presenting plan which you should be there. Okay, so in the next class or in the next video, we just cover the elevation, we just cover the section. Okay, if we can cover here now only, but we'll just it will take long, again video will get more. Okay, so we just do in the next video. Okay, so thank you so much. Hope you will understand all the things. Okay, if you have any doubts, you just contact us. Okay, thank you.